So now we've worked with changing between exponential forms and log forms and going back and forth. We want to talk about two specific logarithmic forms. The first one's called the common logarithmic function. Log base 10 of x is called the common logarithmic function. It's usually denoted just as log of x. So if I see a log without a base written there, I assume that it's base 10. The log key on the sign here is a common logarithmic function. Thus y equals log of x if and only if 10 to the y equals x. So looking at our calculator, if you have the TI-30XS, the log function, base 10, the common log function, is right underneath the second key. So if I need to find the log of 376, I would hit that log key, 376, close the parentheses, hit enter. And that'll give me my approximation. I can then round it to whatever place value they need me to. B here is written in scientific notation, so we do log. I type 1.6, and now I do have this times 10 to the n key, so I'll do that. Put my 7, hit my right arrow key, and then close the parentheses. So that's 7.2, blah, 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 blah. Again, you would then round off to whatever place value it is. So let's try this last one, log 0.0075. Get negative 2.12, blah, 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 blah. And then you again round off to whatever place values. Now the key below this is the natural log key. So that's base e. So log base e of x is called the natural log function. We usually just denote it as ln of x. Thus, if it is written ln, we assume that it's the natural log. And the natural log key on the sine calculator is the natural log function. So this would be ln of 95. So I would go ahead and type, see if I can get out of that glare. Here we go. ln 95. And then I'd round off to whatever place value I needed to. This would be ln 0.08. And then round off to whatever place value they asked us to. And then this is ln 4.5. Now keep in mind, as what these answers are giving you, these are still exponents. So in other words, this is the exponent I would need to raise e by to get 4.5. So in other words, if I took my e function, raised it by that exponent, should get something very close to 4.5. Or like when we did this one up here, if I take 10, raise it, or that was our approximate answer, so I'm going to just put that in, 2.5751878. Notice I get something very close to 376. So let's go head back into the workbook and let's kind of practice doing some of those exercises. So at the bottom of this page, they just kind of remind you what the common and natural log functions are. So if I'm asked to evaluate each expression without using my calculator. So this is base 10. So this is log of 100 is the same thing as 10 squared. So my exponent here would be 2. So in the back of your mind, you can think of it, what do I have to raise 10 by to get 100? That's what you're trying to find. So this one is log of 1 over 10,000. 10,000 is log of 1 over 10 to the 4th, which is log of 10 to the negative 4. So my power here I have to raise 10 by is a negative 4. So that would be our answer. This is natural log e to the negative 3. So my answer here would have to be negative 3. This is natural log of e to the 10. So my answer here would be 10. And the other way to think about it is I'm really composing a function with its inverse. Log functions and exponential functions are inverse functions. So I'm getting the same number I started with. Now here's some exercises where we're going to use our calculator to approximate the value around to 4 decimal places. Then check your answer by using the exponential form. So like here they give you a little quick example. If I do log 43, that gives me my exponent. And then if I take 10 raised to that number, you can see I get something close to 43. Even if I do the rounded value, I still get something pretty close to 43. So they want you to try that with some of these. So let's do this one. We're going to do log of 200. And they said round your answer to 4 decimal places. So it looks like that's going to be approximately 2.3010. Now I'm going to check it. My base here is 10. If I raise that to 2.3010, I get something really close to 200. All right, let's try number 17. Here we're going to go ahead and we're going to take log of 0.074, rounding off to 4 decimal places. We'll get 1.1308. And now I'm going to check it real quick. If I take 10, caret key, it raises it to the negative 1.1308. Notice I do get something very close to 0.074. So let's do the natural log of 200. Again, if I round that off, that'd be 5.2983. So now let's take second ln. I'm going to put in that 5.2983. Again, I get something very close to 200. And let's do number 19. Natural log of 1.005. So that's going to be about 0.0050. So again, we're going to check it. Second ln. Oops, my bad. 0.0050. And again, I get something very close to 1.005. So make sure you're able to do these on your calculator. Again, it's kind of a fundamental thing to be able to do on your calculator. It's going to be what you're going to need for the rest of this section.